Hey guys, Mr. Backerberg here. In this video we're going to look at parallel and perpendicular lines. So when we're talking about parallel lines, two lines are parallel if and only if their slopes are exactly the same. So for example, if we had the equation y equals 2x plus 3 and the equation y equals 2x minus 7. Those are both written in slope-intercept form, so it's very easy to see what the slope of each line is. In each case, we've got a slope of 2, so because those equations have the exact same slope, their lines, when we graph them out, would be parallel to each other. Now in this example, what we're going to do is work on finding an equation for a parallel line based on a given set of information. Now we want our new equation to go through the point P, which is at 2, 3, and we want it to be parallel to the line 3x minus 2y equals 1. So the first thing we need to know is what slope we want our line to have. So we're going to look at this 3x minus 2y equals 1 equation, and right now it's written in standard form, but to find its slope we're going to take this and rewrite it in slope-intercept form. So in order to do that, we need to work on getting y all by itself. So the first thing I'm going to do is subtract the 3x over to the right-hand side. So we get negative 2y equals negative 3x plus 1. And then I'm going to divide by the negative 2 that's in front of the y, and I have to remember to divide everything on the right-hand side by the negative 2. So we're going to get y equals, now here this double negative will turn into a positive 3/2 x, and then 1 divided by negative 2 is just going to be negative 1/2. So as we're working here, we want our new parallel line to have the exact same slope as this original line that we're dealing with. So we need to be dealing with a slope of 3/2. Now we're also given a point that we want our line to go through. It's the point 2, 3. So when we're dealing with a point and a slope, we're going to use point-slope form. So remember, point-slope form is y minus y1 equals m times x minus x1, and our point is going to be our x1 and our y1 value, and then we know that our slope is m. So I'm going to start taking that stuff and plugging it into this equation where it needs to go. So this is going to be y minus 3 equals 3/2 times x minus 2. Now I'm going to work on cleaning this up and getting it in slope-intercept form, y equals mx plus b. So the first thing I want to do is distribute the 3/2. So if I take 3/2 times x, we're going to get 3/2 x. And if I take 3/2 times negative 2, well, we're multiplying fractions together. Negative 2 is a fraction, it's just technically over 1. When you multiply fractions, you multiply the top numbers. So we're going to get negative 6 on top, and then on bottom, 2 times 1 is 2. The left-hand side is still y minus 3. We can do a little bit of cleanup work with the negative 6 divided by 2. So we've got y minus 3 equals 3/2 x minus 3. Now I want to get rid of that minus 3 that's on the left-hand side, so I'm going to add 3 over to the right-hand side. On the left-hand side, that minus 3 and plus 3 will cancel out, and on the right-hand side, that minus 3 and plus 3 will cancel out. So we're just left with the equation y equals 3/2 x. So that equation is parallel to this original equation that we were given, and it's guaranteed to go through the point 2, 3, since we used that point in our point-slope form when we were trying to figure out what our equation would look like. Now when we're talking about perpendicular lines, two lines are perpendicular if and only if their slopes are opposite reciprocals. So if we look at the equation y equals 3/2 x plus 2, and the equation y equals negative 2/3 x minus 7. As we look at their slopes, our first line has a slope of 3/2, and our second line has a slope of negative 2/3. The whole opposite reciprocal thing, well, reciprocal means that the fractions are flipped over. So if we look at the first fraction, the 3 is on top and the 2 is on bottom. If we look at our second fraction, it's flipped over. The 2 is on top and the 3 is on bottom. So they are reciprocals of each other. They also need to be opposites, meaning that one of them is positive and one of them is negative. So our first slope is positive 3/2, and our second slope is negative 2/3. So they are, in fact, opposite reciprocals of each other. So in this example, we're going to look at finding an equation for a perpendicular line given a set of information. So we want our new line to go through the point P, which is at 8, -3, and we want it to be perpendicular to the line 4x plus y equals 3. So we need to know what slope we're dealing with on our original line. So we're going to take that 4x plus y equals 3 and rearrange that to be in slope-intercept form. So what I'm going to do is subtract the 4x over to the other side. So we're going to get the equation y equals -4x plus 3. Now as we look at this equation, it has a slope of -4. In order to be perpendicular lines, our new equation has to have a slope that is the opposite reciprocal of this slope. And when we're talking about opposite reciprocals, reciprocal means we need to flip the fraction over. So as we're looking at -4, it is a fraction that's technically over 1. So flipping that over, we would need the 1 to be on top and the 4 to be on bottom. And being opposites, we would need this slope to be positive. So our new slope that we're going to use is going to be positive 1/4. Now we need to make sure that our line goes through the point 8, -3, so we're going to use point slope form with this point and with our brand new perpendicular slope. So we're going to go y minus the y1 value, which is -3, equals 1/4 times x minus the x1 value, which is 8. I'm going to clean up the double negative on the left-hand side, so that turns into y plus 3. And on the right-hand side, I'm going to distribute the 1/4. So 1/4 times x is 1/4 x. And if I take 1/4 times -8, well, I'm going to turn that -8 into a fraction by putting it over 1. 1 times -8 on top is -8, and on bottom 4 times 1 is 4. Now we can reduce down that fraction. -8 divided by 4 is -2. So we've got y plus 3 equals 1/4 x minus 2. Now to get rid of that plus 3, I need to subtract 3 from each side of my equation. So those will cancel out on the left-hand side, and we will be left with y equals 1/4 x minus 5 as our perpendicular equation. That's going to be it for this video. Thanks for watching.